Hello, hi, and welcome to this video about paper review. Topic on review is wheel defect detection using machine learning. Key terms encountered are machine learning, statistical learning, support vector machines, pattern analysis, railway safety, railway accidents, wavelet transforms, supervised learning, and artificial neural networks. Okay. In this paper, I looked at what the objective of the project could be. It's about using machine learning to detect wheel defects on freight trains in order to prevent damage to the railway infrastructure, so as to prevent some timely, so as to provide timely information on necessary repairs. Problem started here. The widespread use of railway wagons has led to much damage to the railway infrastructure and rolling stock as a consequence of wheel defects. This has shortened the lifespan of the railway infrastructure. This also causes a lot of noise and vibration emissions that are so much costly to get over or to mitigate. So with an early detection of wheel defects on freight trains, critical essential part in preventing damage to the railway infrastructure, and also provide the train operators with timely information on necessary repairs that can prevent further deterioration of the wheels. That's brief about the study. The methodology employed, the project proposed two machine learning methods to automatically detect defective wheels based on the wheel vertical force measured by a permanently installed sensor system on the railway network. These methods will automatically learn different types of wheel defects and predict during normal operation if a wheel has a defect or it's a normal one. The first proposed method is based on novel features for classifying time series data, and it will be used for classification with support vector machines. This classification method promises to increase the reliability of the railway infrastructure. So to reduce the cost of freight train operation and to save additional investments on noise protection measures. The second method employed the deep learning, the deep convolutional neural networks to automatically learn features from time series directly, or maybe to pick it from a two-dimensional representation. That's the methodology. What weakness did I notify, or did I figure out in this paper? The proposed methods do neither require model of the measurement system nor of train dynamics or wheel defects. The methods only enable prediction of defects on wheels where there is no prior understanding of how these defects manifest themselves into the measurements. Which technology is employed in this case? The project was actually motivated by the recent success of the artificial neural networks for image classification. The use of this neural network approach improves the performance on wheels with flat spots and non-roundness by explicitly modeling the multi-sensor structure of the measurement system through multiple instances of learning and shift invariant networks. Contribution of the projects. The main contribution in this study are the two methods of automatic railway wheel defect detection and classification through the vertical force measurements of trains running in full operational speed. Okay, those are the contributions, or that's the main contribution. What does the other work related and the gap in research state? Although there has been some research on sensor systems for wheel defect detection of freight trains, those works previously only analyzes the signal from acceleration sensors and demonstrate that they can visually see a difference between the measurements of wheels with flat spots and good wheels, but they do not propose a method for detection. That is what the previous work could do. So so this works use the wavelet decomposition of pressure signals, but do not propose a method or a threshold for any automatic related defect detections in the wheels. So with this study, it used machine learning to train a defect classifier, which has a big and general advantage that the measurement system is relatively inexpensive, but can show that it can still be used to detect wheels. That is what also can call motivated or brought about this. Algorithms employed in this project, we had the convolutional neural networks brought in, which the CNN is a kind of network architecture for deep learning algorithms and is specifically used for image recognition and tasks that involve the processing of data pixels. A convolutional neural network based architecture is used to automatically extract discriminating features, which it was the main thing guess in this project here. Deep neural network, this is a type of machine learning that mimics the way the brain learns. The DNN for wheel defect detection alleviates the burden of modular to manually construct some features and allows them to learn representations from time series directly. All right. The project employed some data sets, which were two, to evaluate its performance of the different methods of wheel defect detection and classification, which trains various classifiers. The first data set was to compare the wavelet SVM support vector machine with a benchmark flat spot prediction method. The second data set served to demonstrate that the wavelet support vector machine could accurately classify all the three all the three defect types in railway networks. The findings: the study found three metrics for performance evaluation of the methods. One is the accuracy, the precision, and recall. So, whereas accuracy gives the total fraction of correctly classified wheels, precision measures the fraction of correctly predicted defects out of all predicted defects, and recall the fraction of correctly predicted defects out of all defects. The conclusion: the study presented two machine learning methods for defect detection on railway train wheels. The method analyzes multiple time series of the vertical force of a wheel under operational speed and output if a wheel has a defect or not. Both methods are trained automatically on measurements gathered from defective and non-defective wheels. So this study designed a cyclic shift invariant artificial neural network for detection of wheel flats and non-round wheels that model the relationship between the measurements inherent to these defects. Two data sets from different sources were used to demonstrate improved performance for predicting flat spots, shielding, and non-roundness. Recommendations drawn from this project or this study: the study recommended use of timely and targeted maintenance of train wheels as an economic means to reduce emissions. This measure is more important as the density and usage of modern railway networks is steadily increasing, and some failures could quickly disrupt operation of the whole network or parts of it if it is not to be attended to. The study also recommends use of class probability estimates for each class when implementing such a system, and then adapting a threshold for raising an alarm iteratively based on the test performance of the system. So about the future works, what will the future works need to look onto? The future work should aim at integrating external features into the deep learning models, optimizing for precision and predicting severity scores for the defects. I thank you for listening, and good time.